it mean to complete the square? Well, if I have an expression such as x squared plus 10x, this is not a perfect square. I can factor something out of it though, because both addends have a factor of x. This is x times x, and this is 10 times x. So I can factor out that common x. And the terms that would be left behind, after I factor in x out of x squared, I'm left with x. And when I factor in x out of 10, I'm left with 10. So when I factor x squared plus 10x, I get x times the sum of x and 10. I want to draw a picture of this expression. Here's my x squared, and I get x squared by multiplying x times x. I'm going to add on my 10x. And I get 10x by multiplying x times 10. This is a rectangle. And although squares are rectangles, rectangles are not always squares, and this one is not. Its length is not the same as its width. Its length is x, and its width is x plus 10. For it to be a square, the length must equal the width. So I'm going to get rid of some of this up here to clean up the page a little bit, because I just want to use this part of the problem. Okay. Bring my 10x over here. All right, so I have my rectangular area here. If I want to make it a square, what I could do is I could slice this piece in half and then move this bit over here so that it looks like this. After I do that, I have something that looks like this. Here's my x squared. And since this area over here was 10x, when I sliced that in half, this became 5x, and this is the other half, which was also 5x. So x times x gives me x squared, and x times 5 gives me 5x, and x times 5 gives me 5x. So 5 times 5 is the value that completes the square. But I can't just add some new value in and change the problem for solving. So what we're going to do is we're going to say x squared plus 10x equals going to solve this equation using completing the square. So as we just saw on the previous page, when we completed this square, we had to add in a certain value. And that value was 25. If I add 25 to one side of the equation, I must add 25 to the other side of the equation by the addition property of equality. Now I can rewrite this as x plus 5 squared equals 25. All right. And now I can take the square root of both sides. Doing so will cancel out this exponent and leave me with the expression that was underneath. So I have x plus 5 equals the positive or negative square root of 25, and the square root of 25 is 5. Now I'm going to subtract 5 from each side, and I'm left with x equals negative 5 plus 5, and x equals negative 5 minus 5. Negative 5 plus 5 is 0, and negative 5 minus 5 is negative 10. So my solutions are x equals the two values that are 0 and negative 10. We can solve this exact same equation using completing the square, but we can use a slightly different strategy. If I have x squared plus 10x, and I'm going to leave some space for my c value that's going to complete the square, and all of that equals 0. Another way that I can think about this is if I add in half of 10 squared, I can do that, but in order to not change the problem, I either must add 25 to both sides of the equation, or instead of using the property of equality, I could add in a 0 pair. For every 25 positives I bring in, I need to also bring in 25 negatives, because 25 minus 25 equals 0. And I can add 0 to anything, and it will stay the same. So we have, here's my perfect square trinomial. So I'm going to rewrite that as x plus 5 squared. And then I have my minus 25 that I had to bring in with my positive 25 to keep the equation the same, equals 0. And now I can go about solving. I'm going to add 25 to both sides of the equation. So I'm left with x plus 5 squared equals 25. And then to continue solving, I'm going to take the square root of both sides of the equation. The radical and the exponent of 2 cancel each other out, leaving us with the expression that was underneath the radical. X plus 5 equals the positive and negative square root of 25, and the square root of 25 is 5. So I'm going to subtract 5 from both sides of the equation, and I'm left with x equals negative 5 plus or minus 5. Negative 5 plus 5 equals 0. Negative 5 minus 5 equals negative 10. So my solutions are the two numbers that are 0 and negative 10. expression of the equation x squared plus 10x my solutions are located in the exact same places that we found when we solved algebraically. I have an intersection point there. And I have an intersection point there. So there's my two solutions. 0 and -10.